In this module, we are going to learn about another type of supervised classification, which is called as naive Bayes. Naive Bayes is one of the very old algorithm available to us. In fact, it's quite famous with the text classification. We will learn about it, what exactly that means in this case. And it is completely based on probabilistic classifier. So it is going to always return you in the results in form of probability, and that's what makes it very interesting. So we are going to get the result in terms of probability and all that. So given any input, we will get the result of the test data point in terms of output, in terms of probability, that okay, this belongs to this class with the probability of this. So something around that, we're going to get the result. Now let's understand what is this probability term, right? So because we are going to definitely work on this probability part, so it's very important for us to really understand that what is this probability all about. Now if I have to mathematically define it, it is an event which measure the chance of that the event is occur divided by total number of possibilities. Now what does this mean in terms of very simple kind of example terms? Um, when you watch any sort of sports like cricket match, now they always have a coin toss which will return you either a head or a tail. Now, assuming that the coin which we are using is not corrupted, it's basically a good coin. In that case, the probability that we gonna get head is 50% and we gonna get tail is also 50%. So there's a 50-50% chance of both the occurrence which is possible in this case. So in this case, what we can say, what is the likelihood, what is the chance of getting a head? It is going to be 1 by 2. Okay, so we denote it like this. So we say 0.5, which if we multiply with basically 100, we get in terms of percentage. So this is basically called as probability. I'm not going too much in depth of this because we have already learned about probability into our lot of mathematics module. So this is just a quick review of what we have done. But yes, we are going to definitely discuss on further things which is going to be called as conditional probabilities, which is very important for us to understand. So this is the main topic which we are going to focus on. Now again, just to make one more example here. So let's say if there are 30 days in a month, and out of 30 days maybe you are going for play in for 20 days, right? So now in that case, if I ask you the probability that what is the chance that you will go and play outside, so you would always say it's going to be 2 by third. How you calculated 2 by third? You are going to compute 20 divided by 30 and you're gonna get basically in this case 2 by 3 response, right? So this is going to be your output in this case. But now if I ask you that I want a probability that you are going to play, but I am giving you one kind of instance that it is going to rain here. So I'm giving up, I basically want a probability that it's you are going to play. I want that probability, but given that it's raining outside. So now in this case, is your probability going to increase or it is going to decrease? Think about it. Definitely your probability that you are going to play with the condition that it's going to rain is going to decrease. Maybe now it comes down to 10%, right? Which is 0.10. So the reason being because I have added something up. Think about your mailbox. In your mailbox, you like very frequently determine whether any basically any email, if we talk about, is a spam or non-spam. So now usually if we talk about spam emails, rarest of the mails goes to spam box, right? So maybe if I'm getting 5 emails in my mailbox, out of 5 emails, maybe one email out of those 5 is going to my spam box. So my probability that any email is going to be spam is going to be 1/5, which is going to be what? 20%. Let's say this is just an example. The probability that the email is good, like which means that it is a ham. Now this is going to be 4 by 5 because every 4 emails out of 5 emails are coming to my ham box. So this probability, if you look at, it's almost like 80%. Now, if you think a bit that in your email box, when you look at your spam box especially, what kind of emails you generally see in your spam email box. So you will notice that in your spam email box you get something like you won a lottery or some doctory terms, right? So something like that, right? So let's say if I say that the email probability, give me a probability that the email is spam, but I'm giving you a condition here that the word which is occurring in that email is, let's say, Viagra. Now, what would you say about this probability? Now the probability is going to increase, right? Because we know that if this sort of wording is coming up in caps letter, or the word is little clumsy, so if that is what coming up, maybe my probability will increase to now 70% from 20%, right? So now this is basically what is called as conditional property. We are still calculating the probability, but with respect to some event. I'm telling you that this have occurred, then tell me what is the probability of this thing. So this is basically called as your conditional probability. I will give you much more examples to it, so don't worry about that. We will see much more examples that how we will reach to this percentages also. Now let's see few more things. So there is something called as prior in probability, and there is also something called as posterior. Now what is both these terms here? So when I said that probability that you are going to play, this is basically defined as a prior term, which means that let's say you are defining it like 66%. Now similarly, if I say that probability that any email is a spam, now this is again some prior probability for which we already are aware of. This is again called as prior probability. Now in posterior, what comes? Like when I was saying that probability that I'm going to play given that rain have occurred, or when I said probability that it's a spam given that the word Viagra is present into my letter. So this is basically what? This is going to be your posterior kind of probability. Now, how we can define it further? If you look at it, here, if I have to define, let's say, probabilities, so let's say I say that A and B are two different events, okay, two different events. Let me define this events also. Let's say when I say probability of A event, it means that probability that your email is a spam, right? So let's say this means that probability that your email is a spam. Okay, so let's say this is the probability A. Now similarly, we do have a probability B. Let's say we say that probability of word being Viagra. So let's say this is, I'm defining it like this. Okay, this is Viagra. Now what I'm saying here, let's say probability of A is 20%. Probability of A given B, okay, probability of A given B, this is basically, we have discussed earlier that we were saying at 70%. So this is how we kind of provide the notations when we are basically working on this probability, conditional probability term. So here I have defined it in A and B, but usually when you have to write it up, you will just define it in terms of like A, B, C, D, give some letters to it so that it's more easy for you to basically kind of write it down. But nobody is stopping you from writing the full thing if you want to, but this is just a notation which I'm telling you up that how to work it on. Let's take one more example. Maybe let's take an example from the Wikipedia page itself. So for that, what I'm going to do, I'm going to go to the page which is basically a conditional probability page of Wikipedia. So this is where I'm going to take up one example and going to see that how this works. So now let's come and see one of the example from here. So there are very interesting examples on it, but let's take an example of dice. So I hope everybody know what is a dice, right? So a dice is what you play with a Ludo, right? So it has 6 sides what you can use. Now basically if I ask you a probability of some occurrence here, so let's say if there are 2 dices which I'm rolling now, right? And if I'm asking you that what is the probability that, let's say, like value 2 is going to come up. Now what you can do in this case, since you're rolling, let's say, 2 dices, So you will kind of basically and basically when I'm saying that 2 will roll up, I'm talking about, let's say, in 2 dices. Definitely the possibilities, if I look at 1 2 3 4 5 6 from here, and 1 2 3 4 5 6 from here, right? This is the possibility. And if I look at all the permutation combination which are possible while you are rolling the dice, they are 36 in number, right? So when I'm saying that I'm looking for number 2, I'm looking from the dice 1. From dice 1, what is the probability that I am getting basically a number 2? Now what I can do here, I have noted down all the possibilities basically in this case. So in this case you can see that 1 2 with 1 1 can occur, with 1 2 can occur, with 1 3 can occur, with 1 4 can occur, with 1 5 can occur, with 1 6 can occur. Similarly with 2 1 can occur. So basically this part denotes your D1 and this part denotes your dice D2. So now what we are interested in, that dice 1, so there are total 36 occurrences which are possible, but what is basically the probability that dice in dice 1 I'm getting always 2. Now if you are getting confused, what is this number written? This number is nothing but the addition of these two dices. Like if I'm getting 1 here, then I'm getting 2. Similarly, if I in dice 1 2 comes and in dice 2 1 comes, then I will get 3, right? Like this. So again, right now there is no use of it, but later we will see that. So here basically there are 6 possibilities, 6 cases where basically dice 1 can have 2 occurrence with dice 2. So in this case, there are 6 occurrences out of 36 occurrences. So my probability for dice that in dice 1 I get the value 2 is 6 by 36, which is going to be 1 by 6, right? So this is how with this particular visualization you can always calculate this. Now I'm going to change my question. What my question is, I'm rolling my dice, but what I want now is that when I'm rolling my dice, the number which should come out in dice 1 and dice 2, if I add both of them, let's say in dice 1 I got 1, in dice 2 I got 2 number. So if I add both this number, they should always come less than or equal to 5. What is the probability of this? Now it's very simple. Look at the same table. Now you can see here that these are the additions which we have written for all 36 possibilities. So what we're going to do in this case, we are going to look at all the values which are less than or equal to 5. Now in this case, you can see that there are a lot of values which are less than 5. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 possibilities out of 36 where the value can be less than or equal to 5. So here my probability will become 10 by 36. But till now we have not yet discussed anything related to conditional probability. Now let's see where the conditional probability fits in. Now in the same example, if we go down and see now what we are going to do in this case. Now basically we have already seen that there are 10 possibilities where the addition of two dices is equal to 10. But now what I want also, I want to return I want to get the probability that in dice 2 I got the value 2, given that my dice 1 and dice 2 addition should be less than 5. Now here my sample space is no more going to be all 36, but instead my sample space is going to reduce to only 10, because I'm saying that given that d1 plus d2 is less than 5, which means that d1 and d1 plus d2 less than 5 have only 10 occurrences here, and I am looking for the probability that it is returning the value 2. So in this case, if you look at it, the occurrence for 2 is only 3 in this case, and I'm basically only considering the values which is going to return value less than 5 in the sample space where the value is less than 5. So I will get 3 by 10, because there are 3 occurrences where this condition, first condition, is getting satisfied, divided by total number of sample space which belongs to d1 plus d2 less than or equal to 5. This is how we compute our conditional probability. Okay, so I hope you got a clear picture that how you kind of look at the conditional probabilities. So in conditional probabilities, now if you go back and think about the example, so here when we were saying that I'm looking for an email where it is spam, given that word belongs to, let's say, Viagra, right? So when I was using this word, it was basically meaning that first I will look at the sample space where only Viagra is occurring. Then within that sample space, I will look at where the values are spam. Now I hope you are getting an intuition why this probability is going to be higher. Okay, so this is the reason we were getting a higher number, that we said that is going to be around 70%, because this is how the calculation is going to happen. We will discuss few more examples as and when we will move forward in next lectures.